So in the last class, we have completed with resonance frequency, Q factor, bandwidth. We have discussed the questions on the Q factor, resonance frequency and all. Okay, so today we will see the next part of the lesson. Power also we have completed. That is the energy for the LC oscillations we are discussing. Okay, so the next point we are discussing is that is so this we have completed already. We are discussing the LC oscillations and the energy in the LC oscillations. Then after that, the transformer. Okay. So what do you mean by LC oscillations? See. So what is LC oscillations here? There is when a charged capacitor is allowed. So here you have a charged capacitor. So charged capacitor under one plate positive irutte, one plate negative charges irutte. So when this charged capacitor is allowed to discharge through an inductor. Okay. So when this capacitor is connected to the inductor, here this capacitor is allowed to discharge. So now we gain capacitor na discharge through this inductor. Electric field oscillations are produced here. So when you are discharging the capacitor here, what is getting produced here, students? That is, you are getting the electric field oscillations. We are getting the electric field oscillations. So these oscillations are called as what? LC oscillation anta heltare. So what is the LC oscillation here? That is when a capacitor is connected to inductor, the capacitor is getting discharged. So it discharge agbekadre en oscillations produce ಮಾಡುತ್ತೆ. That oscillations is called as what? LC oscillation anta ಹೇಳ್ತೀವಿ students. Okay, it is called as the LC oscillations. ಹಾಗಾದ್ರೆ what is the expression for the energy stored in the LC oscillations? That is, the total energy is given by the energy due to the capacitor. ನೀವು ನೆನಪಿರಬಹುದು capacitor ಅಲ್ಲಿ, okay, that is deleted actually. So energy in the capacitor is given by 1/2 CV square plus energy in the inductor, it is given by half Li square. So the total energy during the LC oscillation is given by the combination of both. Half CV square is due to the capacitor, the energy, and half Li square is due to the inductor, the energy. Okay, so this is the expression for the inductor. Please copy down this formula also. The next point what we are discussing is that is the transformer. So what do you mean by the transformer? How many types of transformers are there? Construction of the transformer, and let us see some of the expressions. Yes. So what is transformer here, students? It is an electrical device for converting and alternating current at low voltage into that at high voltage or vice versa. So here what we are doing, we are converting an AC current of low voltage. So AC current then low voltage irutte. So ಈ low voltage ಅನ್ನ we are converting into high voltage. So low voltage ಇದ್ದದನ್ನ high voltage ನೀವೇನ್ conversion ಮಾಡ್ತೀರಾ, that device is called as what? Transformer anta ಹೇಳ್ತಾರೆ. Okay, so if you see that is the electric poles. So electric poles alla use ಮಾಡ್ತಾರೆ, that is transformer. So road side ಗೆ ನೀವು electric poles ನೋಡ್ತೀರಾ. So in that the transformers will be used. So what is this transformer? What it is doing? It is increasing the voltage of low voltage into high voltage for the AC supply. Okay, or you can also reduce it also. So ನಿಮಗೆ ಯಾವ ರೀತಿಯಾಗಿ ಬೇಕು, based on the requirement we can use it. Either you can increase or you can decrease also. So the device is called as what? Transformer. Yes. Then what is the circuit symbol for the transformer? The circuit symbol for the transformer is given by okay, so this is the circuit symbol for the transformer anta ಹೇಳ್ತಾರೆ. On what principle this is working? It is working on the principle of mutual inductance or mutual induction anta ಹೇಳ್ಬೋದು. So last lesson ಅಲ್ಲಿ ನೀವು mutual inductance, self inductance study ಮಾಡಿದೀರಾ. So this transformer works on the principle of what? Mutual inductance. Okay, or inductance. Next, again in the transformer, we have the two types of transformer here, students. That is the step up transformer and the step down transformer. So as the name is indicating, up means up in marta it is increasing. So it is increasing the low voltage into high voltage. That is called as the step up transformer. So that step down transformer, it is decreasing the voltage from high to low. Yes. So step up transformers, which is increasing the voltage, that is called as the step up transformer. Step down transformer, which steps down and the electrical voltage, is called as the step down transformers. Okay. Hope so this much it is clear to everyone. That is, we have discussed what is transformer, which is converting the voltage from high to low or low to high. On which principle it works? It works on the principle of the mutual induction. Then next, there are two types of transformers we have. That is the step up transformers and the step down transformer. So if you remember the mutual induction, you can see here it is given. See, when a changing current is passed through one of the two inductively coupled coils, an induced EMF is set up in the other coil. So illenagate one coil alli, that is the EMF is changed, the current is passed through the one of the two inductively coupled coils. So through one coil you are changing the current or you are passing the current. In the other coil, what you are observing? You are observing there is a EMF is induced in that. So that is nothing but the mutual inductance. So ನೀವು ಬೇಕಾದ್ರೆ construction of the transformer ಅನ್ನು ನೋಡಬಹುದು. AC source is connected. So this is how we can represent the primary coil. This is the primary coil. And here we can show the secondary coil. This is the secondary coil. We can call it as a load. Sorry. This is the soft iron core. This is the soft iron core. This is the soft iron core. And this is input. Okay. So the input is the primary coil is there, and here we have the secondary coil, and here outside it is connected to the load. And iden coil il wound madidira andre yav riti spiral ag madidira, that is you are doing it for the soft iron core. Getting? Okay. So let us discuss here, students, what is the construction of this transformer. See, first, a transformer consists of two insulating coils. So niಮಗೆ ಗೊತ್ತಿರಲಿ, it consists of the two coils, the two insulated coils, and which is wounded on the first point. Two coils are there. Second point, they are wounded on the which material? That is the soft iron material. They are wounded on the soft iron material. So whatever the coils are there, it is called as the primary coil and the secondary coil. So ಇಲ್ಲಿ ನೀವು two coils use ಮಾಡ್ತಾ ಇದ್ದೀರಾ, ಅದರಲ್ಲಿ ಒಂದನ್ನ primary coil ಅಂತ ಹೇಳ್ತಾರೆ and ಇನ್ನೊಂದನ್ನ secondary coil ಅಂತ ಹೇಳ್ತೀವಿ, students. So in the step up transformer, so suppose if you consider the step up transformer, step up ಅಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ವಿ, we are increasing the voltage, right? So it consists of few number of turns here. So first, how it works, that is principle of the mutual inductance anta nodidivi. Construction alli enella baribekanta nodi, students. It consists of a two coils. It is wounded on a soft iron core, and that is called as the primary coil and the secondary coil. The fourth point is what? In a step up transformer, the primary coil consists of few turns when compared to the secondary coil. So step up ಮಾಡಬೇಕಾದ್ರೆ primary coils number of turns ಕಡಿಮೆ ಇರುತ್ತೆ compared to the secondary coils. So you can say the number of primary coils is less than the number of turns in the secondary coil. Secondary coil ಜಾಸ್ತಿ ಇರುತ್ತೆ. This is primary, this is secondary. When you are stepping up the voltage. So reverse ಮಾಡಿದ್ರೆ you are stepping down the voltage. Yes, construction is clear to everyone. Consists of two coils wounded on a soft iron core. which is called as the primary core and primary and the secondary coils. So to step up the voltage, the number of turns in the primary coil must be less than the number of turns in the secondary coil. So this is the construction, students. Idenaitu construction discuss madidvi. Hagadre working enide, working is nothing but what you have explained here alla, that is the principle, that is only you have to write. When an alternating current is passed through the primary coil, so primary coil alli yava current anna pass ಮಾಡ್ತೀರಾ, a varying magnetic flux is produced around the primary coil. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, primary coil ಸುತ್ತಲ್ಲಿ magnetic flux produce ಆಗುತ್ತೆ. So this magnetic flux is linked with the secondary coil. This magnetic flux is linked with the secondary coil. Therefore, in the secondary coil, an EMF is induced. So this is the working anta helbodu. I'll repeat here, students. What is the working here? That is, when you are passing the electric current through the primary coil, the magnetic flux is induced in that. The induced magnetic flux is attached to the secondary coil, which will induce an EMF in the coil. So this is the working. Construction and working part we have completed. So now the last step, that is the formula, let us see. Okay. So the EMF induced in the secondary coil, sorry, the primary coil is given by, because primary coil alli EMF edrinda barutte due to the secondary coil. So therefore ES is equal to what we are writing, minus NS into d pi by dt. Yen heli, this is the Faraday's law. See, EMF is equal to d pi by dt, where NS is the number of turns in the secondary coil. So this is what EMF induced in the primary coil. Suppose if you are writing the equation for the secondary coil, it will be opposite, because L current pass ಆಗುತ್ತೆ, second idralli EMF produce ಆಗುತ್ತೆ. So therefore, for the secondary coil, it is EP is equal to minus NP d pi divided by dt. This is equation 2. Okay, students. So divide equation 1 by 2. If I divide equation 1 divided by 2. So what is 1 divided by 2? It is nothing but ES divided by EP is equal to, so d pi by t and d pi by t ಮತ್ತೆ negative sign cancel ಆಗುತ್ತೆ. We have only NS divided by NP. This is our equation 3. Okay. So suppose if you are considering this as the voltage, so voltage anta ನೀವೇನಾದರೂ ತಗೊಂಡ್ರೆ across the secondary coil, the equation can also be written as Vs divided by Vp is equal to NS divided by NP. Hope so you know all the terms here, students. NS andre number of turns in the secondary coil, NP andre number of turns in the primary coil, Vs is number of voltage across the secondary coil, Vp is voltage across the primary coil. Yes, till here is it clear? So the last last equation and in madbodu nodi, that is Vs is equal to NP is equal to, we can write it as Vp into NS, or else you can keep it as it is also, no problem. Just whatever the given means ಏನು ಕೇಳಿರ್ತಾರೆ ಅದರ ಪ್ರಕಾರ ನೀವು ಚೇಂಜ್ ಮಾಡ್ಕೊಂಡು equation ಅನ್ನ you can find out that. Yes. So as we know that according to Ohm's law, the current is directly proportional to what? It is directly proportional to current, potential difference and current. So illen equation ide, we can also write this equation as NS divided by NP is equal to, it is IS divided by IP. So that is input power is equal to, okay, one more thing. So here little change I'll do. It is not directly proportional. According to our power, according to our input power is equal to output power. So here what we have, that is input power is equal to the output power. So when it is input power is equal to output power, the input power is what? It is written as what? VI, the power formula. Power is given by product of V into I. So for the primary coil, it is Vp IP, which is equal to output Vs Is. So now you can take the ratios. Vs by Vp is equal to, we will get it as Ip divided by Is. Please copy down this formula also. So the last point, that is the energy losses in the transformer. So transformer alli energy loss ಆಗುತ್ತೆ. ಎದ್ರದ್ರಿಂದ ಆಗುತ್ತೆ ನೋಡಿ students. Actually this part is deleted. So just ನಿಮ್ಗೆ highlights ಅಷ್ಟೇ ಗೊತ್ತಿರ್ಲಿ. It is due to the copper losses. Okay, it is due to the eddy current losses. Actually eddy current is also deleted for you. It is due to the hysteresis loss. Hysteresis actually you should study in the magnetic material, that is also deleted. Flux leakage, just remember terms ಅಷ್ಟೇ ಗೊತ್ತಿರ್ಲಿ because this part is deleted. Just terms ಅಷ್ಟೇ remember. The energy loss in the transformer is due to these 4 factors. So you can say due to the heating, due to the eddy current loss, due to the hysteresis loss, due to the flux leakage. So last one more formula you take down. The efficiency of the transformer is given by, that is output power upon input power. So you may remember in the refrigerator Carnot cycle we will study this. The efficiency is given by output divided by input. Here it is output power divided by input power. Yes, till now any doubt is there? Please ask students. So remember the formula. We are going for the questions now. Okay. Yes, I'll share the questions. 1 minute. First we have the MCQ questions. Few 10 MCQs we will discuss. Then we can go for the that is numerical sections. Okay, so here you can see whatever answers you know, you can answer the students. So see the first question. When the frequency of AC is doubled, the impedance of the LCR circuit is, what happens to the impedance if the frequency is doubled? Yes. Decreases, doubled. See the formula list. Open the formula list and check. When the frequency of AC is doubled, what happens to the impedance in the LCR circuit? So it is option C here, students. So actually C it is reduced to half. It is reduced to half. Option C is illi C andre D agatte. Actually it should be D. So please keep the formulas in front of you. So here the first question, when the frequency is doubled, the impedance in the LCR circuit is, or whether it is increases. So here if I see the equation, so see that is equation what we have, Z is equal to under root of R square plus XL minus XC whole square. How the LCR circuit barutte. So frequency anta andre here XL can be written as what? 2 pi FL, and XC is also written as what? 1 upon 2 pi FC. Correct. So as you can see the equations, if I multiply this inside it ಒಳಗಡೆ ಎಲ್ಲ simplify ಮಾಡಿದ್ರೆ, what they are saying, it will be increasing. It increases. Okay, option B is the correct answer. Yes, option B is the correct answer. It increases. Go for the second question. A metal ring is held horizontally. A metal ring is held horizontally and a bar magnet is dropped through the ring with its length along the axis of the ring. The acceleration of the falling magnet is. So what happens to the acceleration of the falling magnet? Whether it is more than acceleration due to gravity, equal to acceleration due to gravity, less than g, depends. Less than g. So what they are saying, a metal ring is held horizontally. So ring, you are holding it horizontally and the bar magnet is dropped through the ring. So ee ರೀತಿಯಾಗಿ ಇದನ್ನ drop ಮಾಡ್ತಾ ಇದ್ದೀರಾ with its length along the axis. With its length along the axis ಅಂದ್ರೆ ಈ ರೀತಿಯಾಗಿ ಬರುತ್ತೆ. So what will be the acceleration of the falling magnet is? So falling magnet is the acceleration. So here what happens, that is the electromagnetic field will be generated here. So when the electromagnetic field will be generated here, what happens? This is the north pole. This behaves as a south pole. Okay. So according to the south pole of the ring and the south pole of the magnetic bar. So the south pole will repel each other. So the south pole of both will be repelling each other. Thus, the movement slow agate. So movement slow agate andre yen helbodu. It is reducing or less than g. So as the poles are repelling here, due to that the motion is reducing. So motion is reducing anta andre acceleration due to gravity is less than g. Go for the third equation, students. An alternating current of frequency or F is flowing through a resistance R and inductance L connected in series. The impedance of the circuit is. So what they are saying, an alternating current of frequency F is flowing through the resistance. So in circuit alli resistor is there and in the circuit you have the inductor. So resistor is there, inductor is there. They are connected in the series. What happens to the inductance? So the inductance is equal to what? It is under root of what? R square plus, it will be XL square. So that is nothing but what? R square plus XL is nothing but 2 pi F into L whole square. So option C. Yes. This is R square plus 4 pi square F square L square. Alli frequency ana V anta new anta tagondidare. Yes, C is the correct answer. Go for equation 4. You need to calculate the peak voltage. What is the peak voltage? Yes, according to question number 4. An electric lamp is connected to 220 volt and 50 hertz supply. How you can calculate the peak voltage? So peak voltage is nothing but maximum voltage. In the given question, IRMS is given and frequency value is given. How to do the peak voltage? So just you can do it as what? That is, we know that, voltage alla. VRMS is equal to V0 upon root 2. Namuk bekagirodu V0. So therefore V0 will be VRMS into root 2. VRMS is given into root 2. So if you simplify, you will get 311 volt V0. So frequency is given. Usually frequency kottare AC chapter alli, but it is not compulsory to use every time. So frequency you can, because AC in India we have the frequency as 50 hertz only. Always it is constant. Yes, option C. Correct. Hope so it is clear to everyone. Next question, question number 5. An AC voltage source of variable angular frequency omega and fixed amplitude A is connected in series with capacitance C and an electric bulb of resistance R. when omega is increased, an AC voltage source of variable angular frequency omega and fixed amplitude A is connected in series with capacitance. ಹಾಗಾದ್ರೆ ಬಲ್ಬ್ದು omega ಏನಾಗುತ್ತೆ angular frequency. The bulb glows brighter or dimmer. Yes, that is option B is the correct answer here, students. The it brighter, yes. This one will be it glows with brighter value. Go for question number 6, simple question 6. Question number 6. Write the relation between inductive reactance and frequency. What is the relation between inductive reactance and frequency? Inductive reactance is given by XL. So XL matte frequency gain relation ide. Yes, it is option A. Yes, option A is the correct answer. That is XL is equal to 2 pi FL. So B is what? It is the relation between linear frequency and angular frequency. A is the relation between inductive reactance and the frequency. Write the unit of inductive reactance, students. Again, very simple question. Yes, it is ohm. Option A is the correct answer. Go for the next question. Question number 8. The frequency of AC source is doubled. What will be the new reactance of the inductor? Means XL. What happens to XL if you are increasing the frequency to double? Again, based on the formula, you can answer this. D, that is the frequency of AC source is doubled. F is doubled. What will be the new reactance? Increases. Yes, increases anta helbodu. You cannot say it as A. Why? Because ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ನೋಡಿ, XL is equal to what is the formula here, students? XL is equal to 2 pi FL. So frequency double ಆಗ್ತಾ ಇದೆ ಅಂದ್ರೆ 2 into 2 4 times ಆಗುತ್ತೆ. XL will be 4 times. So therefore increases ಅಂತ ಅಷ್ಟೇ ಹೇಳಿ, it also becomes doubled will be a wrong answer. So ಗಡ್ಬಡಿಯಲ್ಲಿ ನಾವು A choose ಮಾಡೋ chances ಇರುತ್ತೆ. It only increases. Option D is the correct answer. Yes, next again based on the definition, amount of opposition offered by the LCR circuit is known as. LCR circuit ಅಲ್ಲಿ opposition ಗೆ ಏನಂತ ಹೇಳ್ತಾರೆ? It is called as what? It is impedance. Option A is the correct answer. Go for the next question. The phase difference between the current and voltage in the resistor. Yes, we have covered this. In case of resistor, okay. So inductor, capacitor, resistor. It is B, 0. Yes, very good students. So resistor ಅಲ್ಲಿ 0 ಇರುತ್ತೆ. By chance if they are asking for that is inductor or capacitor, it will be 90 degree. The efficiency of an ideal transformer. Ideal transformer. ಯಾವುದೇ ideal ಇದ್ದಾಗ ಅದರ efficiency ಎಷ್ಟು ಅಂತ ಹೇಳ್ಬೋದು. Question number 11 we are discussing. B, 30%. 11th question. See, whenever you have any ideal circuit or anything ideal, it will be 100%. Okay. The efficiency of the ideal transformer will be 100%. Frequency of DC sources. What is the frequency of DC source? Yes. Whether it is infinity, 0, 1 or half. 0 or infinity. Yes, 0 is the correct answer. For the DC circuit, it will be a DC source, it will be 0. What is the frequency of AC mains in India? Many times I told you about this. What is the frequency of AC mains in India? 60, 50, 40, 30. Yes, it is option B. Yes, it is 50 hertz. Option B is the correct answer, 50 hertz. Go for the next question. Question number 14. An alternating current can be produced by choke coil, dynamo, electric motor, transformer. Alternating current. Please don't say transformer because transformer ali we increase and decrease it. Yes. It is electric motor or it is dynamo. C. Yes. So AC generator will give you a current, AC current. Okay. So dynamos are also called as what? A generator. So dynamo anna generator anta ಹೇಳ್ತಾರೆ. Okay. AC generator inda namge alternating current ಬರುತ್ತೆ, not by the electric motor here students. So option B is the correct answer. So hope so you understood. Dynamo is also called as generator. Next question number 15. Which of the following can measure an alternating current? AC, how you can measure? AC is measured by voltmeter, ammeter, suspended coil galvanometer, moving coil galvanometer. B, yes, yes, option B. That is the ammeter. Go for the question number 16. Which of the following circuits exhibits maximum power dissipation? So maximum power dissipation will be Whether it will be in inductor circuit, capacitor circuit, resistive circuit, none of the above. Yes, it is option C. What is that C? The following exhibits maximum 16. Okay. Resistive circuit. So resistive circuit, the power dissipation will be 0. Okay, cos pi will be 0. Hagadre 1 agate. Yes, it is for the resistor. Correct here, students. That is for the resistive circuit, because inductive circuit, capacitive circuit, only pure this one will be 0. Next, question number 17. What happens to the inductive reactance when the frequency of the AC supply is increased? XL. What happens to XL when the frequency of the AC supply is increased? So it is almost repeated anta helbodu. Inductive reactance will be increases. Option A. 16th answer. 16th is C is correct. Resistive circuit. Because pure inductive capacitive circuit, it will be 0. 18th question, students. What happens to the quality factor of the LCR circuit of the resistance is increased? Quality factor Q is equal to, if you see the formula, you will understand. Adral resistance increase ಮಾಡ್ತಾ ಇದೀರಾ, ಹಾಗಾದ್ರೆ quality factor ಏನಾಗುತ್ತೆ? What happens to the quality factor of the LCR circuit when the resistance is increased? Decreases. Or increases. Yes, yes, correct answer. That is C. 17, it is remains the same. Sure. It will decrease here, students. That is, the quality factor will decrease if you are increasing the resistance. Option A is the correct answer. Which of the following statement is true about the LCR circuit connected to an AC source at resonance? LCR circuit is there connected to AC source. Idರಲ್ಲಿ ಯಾವ್ದು correct ಇದೆ? R equals the applied voltage. R is 0. C is 0. L equals the applied voltage. A. Yes, very good. Option A is the correct answer. 19th question, option A is the correct answer. R equals to the applied voltage. Last question. The impedance in the LCR circuit is minimum at the resonant frequency. Whether it is true, false, maybe or no. The impedance in the LCR circuit is minimum at the resonance frequency. Current will be maximum. So obviously the impedance will be minimum. It is true. Option A is the correct answer. Yes, it is true. Option A is the correct answer here, students. Okay. So tomorrow we are discussing some numericals on this chapter. Please practice the formulas today. Tomorrow we will meet with the numerical questions. So this completes our total 7 topics out of total 14. Okay. Meet you tomorrow. Thank you.